existed.
Okay, you should be able to see that. One great thing about teaching technology stuff is things are always changing. And one bad thing about teaching technology stuff is things are always changing. It makes it really hard to keep up with everything. And sometimes it makes it hard to decide what to teach you guys, because there are some really advanced capabilities in C# that have to do with sorting and searching. But I always go back to that idea of having that solid foundation to build on so that you can take advantage of those more advanced tools. And so the searching I did last night, the Googling, sometimes I do that when I'm preparing, and a lot of people said, oh yeah, you still have to teach the basics of sort, even though you guys can use a built-in sort in just about anything. You need to know what's going on behind the scenes, and like they said in the article I was looking at, if we'd have just settled on one pre-built sort, then nobody would have ever come up with an improved algorithm. And so it's nice to always have improvement. So in this section, we're going to be looking at advanced collections. In C#1, we only worked with arrays. We didn't work with array lists or any of the more advanced collections that C# has. We did work with our list box on the form, and that's about the same. This thing just doesn't work for me. So whenever we're working with arrays or collections or groups of data, we have to be worried about performance. And we have to be worried about performance because if we allocate a very large array, it can take up a whole lot of memory. And if we allocate that array over and over and over and over, we can take up all the memory and wipe out a system. Plus, we can have things that run seriously for days. They had that little 3D animation class on Fridays, and one of them searched the other day for me, and I said, go look, how long did it take to do rendering for Frozen or something like that? And he came back, it took like 47 days for each blah, blah, blah. And seriously, that's the kind of time that we see. So we're used to things being instantaneous, but we still can really bog a machine down and really slow things down tremendously. So we always have to be concerned about performance and the complexity of our algorithms. We can write code to get things to work, but that doesn't mean it's the most efficient or most effective code. And we have to be concerned about that because our code could be running millions of times somewhere, and every time it runs, if it's inefficient, it could be having a negative impact on performance. So as we look at data structures in this section, we want to be thinking about data formats, data structures, how data is built, and how those structures will work best for the performance of our application. So when we're thinking about data, you guys here will learn how to work with some different data structures. I take the data structures class and get much more in-depth into it, which is great. And from a science standpoint, you might go on to get your 4-year degree, and you might eventually do a software project with a lot of data. Kind of depends on your field. This is something that my son, working with students at OU, working with meteorological data, they're always working with tons of data. And so their performance is something they always have to think about. Here in our environment, we can control that test data to where we just have a really small amount. And so we don't usually get in a situation where we have to worry about it too much. I know you guys were talking about in data structures, him asking, you know, if you have an array this big, that's the kind of stuff that we've got to think about, because what could we do? What kind of impact can we have? And slow it down. So we want to make sure that we understand all these data patterns. One thing, sometimes students will really overthink stuff, and this is not rocket science. We're just thinking about common ways to store data, sort it, search it, all those common things that we have to do all of the time. there are data structures that are predefined that will help us with those things. And some of them are defined or more suited, for other functions. But all in all, knowing more about some of these data structures just gives you more tools for your toolbox. And one sort of tool is Big O notation. Big O notation is kind of like the worst possible case. So you can take an algorithm and apply like Big O notation to it and say, how poorly could this algorithm perform? What's the worst possible case we would see in the performance of this algorithm? So the first Big O definition is this algorithm has a constant runtime. Every time we run it, it will compare one thing to another thing. That's it, one comparison, and it'll be over. So that's constant runtime is referred to as O to 1, or you might see it written this way, the O with the 1 parentheses around it. So whenever we're looking at a constant runtime, we don't care how many elements are in some array or how many elements are in some file, this algorithm is only going to do one comparison. So it's constant. That's the minimal impact we would have on performance. Next, we could have a linear runtime. And this is where we take an element and we compare it to every other element in an array or in a collection. So as our array grows, our array being n, as the array grows, the number of comparisons our algorithm performs increases, right? Because if our array only has 10 elements, we're going to do 10 comparisons. If our array has 100 elements, we're going to do 100 comparisons. So this is called a linear runtime. This is O on the order of n, or order n. As n increases, the runtime requirements will increase. Those resources are in direct proportion to n. How big is the array? Now, a quadratic runtime is where every element in an array is compared to every other element in an array. So now we have a big change in performance as the size of the array increases. This is considered O on the order of n squared, or order n squared, because every increase in n results in a quadratic or a squared increase in resource requirements. So again, if we have an array with 100 elements and we compare each to each other, we're going to do what, 1,000 compares? Help me with math. But if it's 1,000, then we're going to do 100,000 comparisons. So as we increase the size of the array, it's going to dramatically increase our resource requirements. So this is a little intro to Big O. This presentation, like I said, is on Canvas. There's a link out there to this website that talks a lot more about this Big O theory. I'll take a quick look at it. It's got some information, some articles, some different write-ups about things. So we just want to be aware, because again, if we are creating a program that is quadratic performance, you know, when the size of our file increases, we're going to have a major increase in performance requirements. Okay, so let's talk about searching. I've got an array here of data, and I need to find out if something exists in that array. This is a really common thing, right? So if you're in the SQL class, you know that that's kind of what the whole purpose of SQL is. Find something, let's search for something. So our first search is a linear search. And a linear search is where I just look through the whole array to see if I find this value. I'm going to click on this animation here to go to a linear search example. Now, when I'm searching in a linear fashion, let's say I want to search for, oh, what do I want? 404. Now let me type. I don't like this animation. Let me find the other one I used to use. I'm going to go to this one that says Linear Search Animation by Daniel Liang. That's our Java textbook, and I just like this animation a little better. It's a little simpler. I'll fix that PowerPoint. Okay, so here's this array. We have this array here. It has 20 entries. Down at the bottom are our index values. In this array, we have these different values. So it's just an integer array. It's not sorted in any sort of order. Our values are just out there. So I'm going to search for this key 8. So I'm going to start my search by clicking step. And I look at the first entry. Is 8 equal 14? No. So I'm going to check the next entry. Is 8 equal 17? No. So I'm just going to keep stepping through every entry in the array, searching. If you notice, it's very inefficient. And I continue searching until finally I find that given value in my array. Now that's a linear search because I just start at the beginning and go down the line, right? Checking each one. Does it match? Does it match? Now, if you look at that linear search, what's the worst possible performance? Well, the size of the array, right? And as the size of the array increases, so would our performance requirements. So a better form of search is a binary search. And in a binary search, we are using a binary capability, and we're going to search the array by splitting it in half. So you guys have all seen this. Have you ever watched The Price is Right? Have you ever watched that part where they do the high-low game? You ever seen it? Where he says, how much is this car worth? Or, well, let's be a small car. I'm going to do something that's $1,000. So how much is this ice cream maker worth? And the person will say, $500. And Drew will say, no, higher. And then if they're smart, they'll say, 750. And he'll say, no, lower. And then they'll split that difference between 500 and 750. Have you ever seen people do that and win that contest really quick? And then there's those dumb people that go like, 5, 23, 14, and then they just have absolutely no rhyme or reason, and they're not going to be able to guess that price. But if they split the difference and guess that, and always get told higher or lower, that's a binary search because they're split it in half, and that's what they're using as their guess. So again, it looks like this animation is at that same site, so I'm going to have to find my other one because I would rather use this Liang one. I'll search for binary search.
Doesn't this require our array to be sorted though? This wouldn't work if we don't know what.
That is such a good point, and you are absolutely right. Our array has to be sorted before we can take advantage of the performance improvements offered by this binary search. So it's a trade-off. Is it going to cost us more in performance to sort this array than it would to just do a linear search? We're always going to have to think about things like that as a trade-off because that's some overhead too to sort it. Okay, so here's our binary search. We're again looking for this key 8. So when we start our very first step, we're going to check the middle entry in the array. We're going to say, oh, that entry is higher, so you can eliminate this whole half of the array, the top half, and split what's left and compare. Now, the number we're looking for is higher than 5, so we'll eliminate this whole bottom half of the remaining array entries. Whoops, I messed it up. And then we'll check the 7. We'll see the number we're looking for is higher, so that will eliminate the 6 and 7, the last half. And finally, we'll find our answer. So if you notice, we found it substantially faster in much fewer comparisons than what it took for the linear search. So binary search is super efficient. So if we have to sort that data, what are we going to do about sorting it? We don't want to lose all that performance improvement because of our sort. Well, there are several different types of sorts and lots of different algorithms in use. Like I said, you guys might find even a better way than they found. So let's look at some sorts here. This is a selection sort. See if we've got sound. We should.
In this lesson, we are going to show how the sorting algorithm selection sort works. Its function is to find inside the data structure the minimum element, and when it is found, it will be moved in the first position. Repeat this procedure for the remaining
Figure this weird 3D guy will get stuck in your head forever.
Sorted. The maximum number of comparisons of this algorithm is by multiplying n for n minus 1 divided by 2, where n is the number of the elements. And now we are going to see how the algorithm works with a 3D animation.
So in this sort, the entire array is being scanned, right, to find the lowest value. That lowest value then is being swapped with the current search position. We're going to have to swap that time. Now every time he starts back over, we would call that another pass, a pass of the data. And as you watch him, you're probably thinking of ways that it could be made more efficient just as you watch. That's the beauty of a visual, right? Much better than when you're coding. Like, oh, that looks so easy. Now we know it's all sorted, but it still has to all be double checked, right? So we still have to finish processing the rest of that array to be sure that those last ones were in the right order. Okay, so beautiful selection sort.
Why would you do that to us?
You'll remember it. Now these ones are even better. Here's an insertion sort. Now notice the differences and think about coding this. How would you write this code? We might have to stop it before they get all the way done. But notice their index values are at the top. So in this one, the first position compared to the second, and then they swapped if they needed to. So it already seems a little more efficient, right? Because instead of processing the whole array, we're kind of moving things as we go. So think about what you would have to be keeping track of. That beginning position they're comparing and swapping all the way back to that beginning position for this cycle. Sorry. Then they can all dance. Okay, so there's like,
I wonder who's like, let's display sorting dance.
I don't know, but there's a whole series of them out there. So anytime you're interested in a sort, you can find Romanian dancers that will dance it out for you. So I guess they just had a lot of time.
I'm guessing there was probably a computer scientist that was friends with that dance group.
Maybe so. Wanted some training videos. Okay, let's think about a merge sort. A merge means I have two separate things and I'm going to combine them together. So in a merge sort, we're going to be splitting things up, kind of like a binary search, and sorting smaller pieces. I know you love 3D guys, so here he is. This one's not it.
In this lesson, we are going to show how the sorting algorithm merge sort works. Its function is to divide the elements in the data structure into smaller partitions and sort them. Finally, must we merge the small partitions to make the original set with sorted elements. This strategy is called divide and conquer.
His music is a little more. So again, think about coding this because it's much easier to watch it than it is to code it. He's getting that first set in order and then the second set. And I don't know why he's so delicate putting them all back together, but whatever. Now he's going to merge them. So he's going to decide which one in which set goes first, each merge operation. Got it. So you can see the merge happens much quicker. I just sort of spread it out there. So that would be the most efficient sort and also the most involved logically, right? Because you're going to have to do a lot of different work there. This one's kind of cool. And this is something, do full screen. Why won't it full screen? Come on, you silly. It's not doing it. Hang on. Silly PowerPoint. Yeah, I'll do it there. It was supposed to. Pretty easy to find. So there's a few out here that are different visualizations. This is a selection sort. And remember, that was where we compared one to the next and swapped them. And insertion sort. This is called a quick sort, and you can see how they've implemented many of those different algorithms together. So they're doing like little sections of data at a time and then merging it back together. You can see it's pretty efficient and quick. Call it a quick sort. And this one is an actual merge sort. That's just a merge sort. But again, you can see they're sorting sections and then kind of putting them all back together. So it's kind of cool to visualize it because you can see that it's not just two chunks of data. And this is a heap sort. So you can see this one is, the one we're going to do in class is a bubble sort, and a bubble sort sort of looks like this too, because the high entries go to the end of the array as you're using that algorithm. This is a radix sort, which is like a bucket. So we're trying to put data into individual array entries based on its value, and then we sort those values and merge them together. So that's a pretty fast one. Here's another radix. Different way of handling it, but the same type of algorithm. So the radix or bucket sort is kind of considered the fastest, but I'm sure it's changing all the time. This is like GCC, just a C compiler standard sort, which seems very fast.
So like that one did something to get it generally sorted.
Right, it's weird, isn't it?
Something like an insertion sort to eat data.
Yeah. It's like a lazy sort and a final sort of thing. And I don't know why this is a stable sort versus the other. They're both C compiler sorts. But it does more of the bucket sort and merging. This is a shell sort, so from the Linux shell. I'm not sure which Linux. But again, it's pretty fast. So this would be if you just issued a sort from the command line. Now this bubble sort is, like I said, what one of our assignments is. The bubble sort is finding the biggest entry, moving it to the highest point in the array. So it's pretty fast. It's cocktail shaker sort. Never quite figured out what's going on there. Sort of a merge, sort of some buckets. working its way. And this is a GNOME sort, so if you're using Linux, the GNOME very and it's pretty efficient. This one's really cool. It's just like doing all sorts of different things. Big tonic. This is the BOGO sort. We've searched, it says, it's like buy one, get one. It says it actually never actually does any, accomplishes any sorting. So I'll stop it. Yeah. I think it would stop eventually, but we'll stop it. It does stop eventually. But it doesn't really do much sorting. So lots of different algorithms, lots of different things that we can try. How exciting. And we have to always be aware that, again, performance is our fault. We're going to walk through this program. And so this is the one I gave you the source code for. I'm going to pass out some Post-it notes, little ones. And that second sheet I gave you, we want to make it be an array. And we're going to put some Post-it notes in our array, try some values, and then we can move them around if we do some work here. It doesn't matter what color you use or anything like that. Your Post-it notes. There's some. Just anything is fine.
A question, because I'm noticing a mild inconsistency. These sheets of paper have 4 squares on them.
You're going to need them side by side.
How many sheets are we each supposed to have?
2.
2. And no more than 2.
Right.
And no less than 2.
You should have 2 of the squares.
What have you got?
Now, I'm going to do like that one guy. See if I can move this. I'm pretty stressed about having to rearrange here. See if I can do it. All right, I need some bigger ones. Sure. Yeah, anybody else? There's some pencils up here if you need them.
We have to.
No. Just if you want them. Okay, so I'm going to try to get all my stuff over here and see if I can do this. So I want to have some array entries like you guys do. So I'm going to put them up here on the board. I think 5 is about enough, just because that's more fits on your sheet. And then I'm going to put a Post-it note in each of those. I'm going to use some different colors so that I move these around. And then if you notice, looking at that code, it generates some random numbers to fill up the array. So that's what we'll do. But let's all use the same random numbers. Yeah, I don't know if they'll fit.
Oh, they fit.
Do they fit? Different size little Post-it notes. Thought they were stable. Okay. So now I have a Post-it note in each of my squares, and underneath my squares, I'm going to write my index value. So I have 0, and then I have 1, 2. And you guys should have little square brackets on that sheet. So there's my index values. And then my data values, let's see, I think I'm going to do, we'll go 47 15, 8, 15, 1. How's that? We'll get it kind of out of order so we can tell we've got some sorting to do because our numbers are not in the right order.
We're not using all 8.
No, it would take us forever. You guys will be, we're done. Okay, so I need some other variables. So if I'm going to do this walkthrough. So if I look at my code here, we started out with the size of our array, which is just 5. So I'll put that down. What's our array called? Data. So our array is data. And then we know that data.length equals 5, because that's how big our array is. So this first method here, actually in this particular instance, it was our constructor, built this array and filled it up with random numbers for whatever size this code said it was. So that's some nice code to have. Now, if somebody calls our sort method, we're going to use that data array. And I want to make sure to get all of the other variables that I need allocated here for my walkthrough. So I need a variable named insert. Right now it doesn't have a value, so I'll just put insert equal. And then I need a variable next. Next is going to hold my position in the array. And let's see, we have our data.length, insert, move item. And I'm just going to get all of my variables here written down, hopefully, so I can walk through this without having to do too much else. I think that's all that we need. All right. So if we start here, as we begin looking at our sort method, the first thing we do is go into this for loop. Now, I'm going to go ahead, because my next variable is an index, kind of like a pointer into the array, I'm going to make a post-it note for it. And I'm going to make it just kind of point up into the array. And I'm going to put the word next on it. Let me get this up here so you can see it. I have it upside down. So that's going to be my pointer because it's an index. It looks like move item is also going to be used as a pointer, as an index. So I'm going to create another pointer one for it. Get everything ready here. Here's my move item pointer so that I can keep track of where we are in our array. Okay, so I think we're ready to start. So the first thing we're going to do is go into this for loop, and we're going to set the value of next to 1. So I'm going to put that 1 here, and I'm going to put my pointer right there where it's pointing, right? Because it's a value of 1. So I skipped that first one, right? I skipped the 0 entry right off the bat. What? And we'll see why. Now that I've got my next set to 1, the first thing I want to do is store the value in my current element in my insert variable. Okay, so I want this 15 to be stored in my insert variable. Now I really still have 15 here. Just because I moved my post-it note, it still has that same value, but I saved it there in my insert variable. Now, I'm going to initialize move item and set it equal to next. Okay. So move item is going to be 1, and they're both going to be pointing to the same entry in the array. Both my pointers. So I'm just getting started. Now, since I finally have myself set up on this pass, I'm ready to make a pass here. We're going to go into a while loop. And in our while loop, we're going to say while move item greater than 0. Is that true? Yes. And the data at move item -1, so that would be move item -1. What would that be? 47? Because move item -1 would be pointing here. So the data there would be the number 47. Is the number 47 greater than what we saved in our insert variable? Yes, it is. So we're going to execute this while loop. In our while loop, we're going to say, take the data at the position of move item, which is our number 15, and set it to the data at move item -1. Okay? So that was my move item -1. I moved it into my move item, right? And now subtract from move item. So now move item is 0. We're pointing right here. So I'm going to go back up to my while loop. And it says while move item greater than 0. Is that true? Nope, it's not. So I'm going to drop out of that while loop. And I'm going to execute this line of code that says, set the data at move item's position equal to what you saved in insert. So there's my swap of those two. Okay? Now they're going to go ahead and print out some information because this was one pass, basically, of the data. Now we come back up to our for loop. Is next less than data.length? Yes. So I'm going to add to next. Next becomes 2, and now it's pointing to this index entry. And then we say set insert equal to this data, add dot next. Set move item equal to next. And now they're both pointing to that one. Now remember there was an 8 there. Now we're going to go into our while loop. While move item greater than 0. Yes, it is. And the data at move item -1, which is our number 47, greater than the data at insert. Yep, it is. So we want to shift them. So I'm going to move the data at move item -1 to the position of move item. And I'm going to subtract from move item. So now move item is 1 again. Now I'm going to reevaluate my loop. While move item greater than 0? Yes, it is. And is the data at move item -1, this would be our 15, greater than the data at insert? Yes, it is. So I'm going to move this over, subtract 1 from move item again, so that it's now 0. And I'm going to evaluate my while loop again. Is move item greater than 0? No. So I'm going to fall through. The data at the move item, which is 0, is going to be set equal to what we saved in our insert variable. That going? Now we're going to check. Is next greater than or less than data.length? Yes, it is. So we're going to add 1 to it. Next is going to become 3. As we begin this pass, we're going to save the value into insert, and then we're going to set move item equal to next. Now in our while loop, the data at move item -1, number 47, is not greater than what we've saved. So we won't execute our while loop. We'll just drop down and take whatever is in insert and move it to our position pointed to by move item. So we're just going to put that 50 right back, right? Because we didn't do any swap in that time. We didn't need to switch anything. But we still have to process it. Okay, so that's going to take us back to our for loop. And in our for loop, we're going to add 1 to our next variable. Now I'm going to save the data to our insert variable, and I'm going to set move item equal to our next variable. Now this one is going to take a while, right? So now, is move item greater than 0? Yes. Is the data at move item -1, which is that number 50, greater than our insert value? Yes, it is. So I'm going to move it and subtract 1 from move item. It's going to put me back to the while loop again. Is move item greater than 0? Yes. So now I'm going to check, is the data at move item -1 greater than insert? Yes. So I'm going to move this, and I'm going to subtract 1 from move item. Now my while loop, again, is move item greater than 0? Yes. Is this number at move item -1 greater than the value of insert? Yes. So I'm going to move it. And I'm going to subtract 1 from move item. And then finally, my last execution of the while loop. Move item is greater than 0. The data at move item -1 is greater than our insert value. So I'm going to move it. I'm going to subtract 1 from move item. So now I will not meet the condition of the while loop. I'll fall through and set that final value back to our insert value.
A question that just occurred to me. How would this insertion and sort manage multiple values that are the same? Like you've got an 8 up there, for instance, and you've got a 50 up there. Suppose instead of that 50, you had another 8. How would it have been different when it got to that point where it realizes, oh, there's 2 8s here?
It wouldn't do anything different. It would just be when it hits this, if the data is greater than insert, it wouldn't be. So it would just leave that second occurrence in the entry right next to it. Yeah.
Okay.
So you would just end up with them side by side.
So if you had an array full of just different instances of 3 different variables, it would just sort them into groups effectively.
Pretty much. Okay, any other questions? Go through it, keep your stuff. So I really like doing that with our Post-it notes because I think it gives us a visual of what's going on. It can be kind of annoying, but it's also very much of a visual for us. So that was this insert sort. And there are so many other sorts you guys already saw in all those videos. Oh my goodness, there's just tons. So we have so many different algorithms we can try. But you want to get to the point where if you see some code like this, where there's a lot of index -1 stuff, they're probably doing some sorting, right? And so you can actually even hit a question or two like that in the certification exam at the end of the semester, and it'll have some sample code like that and say something like, what is this algorithm attempting to do. And if you just remember, oh, when I see index value -1 and swapping a lot like that, it's probably doing some sort of sorting, some sort of manipulation of the entries in the array position. So things like that. All right. So let's write us one. I want to open Visual Studio because we want to make our own. So I think let's just create a console app. Good old console app. Can I find one of those? And I'm going to do .NET Framework. And I'm going to call this sort util, like for sort utility, because we could have all sorts of different sorts in this class if we wanted to. I think it's putting on my OneDrive, and then I'm not sure. I'm probably going to send this to GitHub. Yay. So just like that code that I handed out to you, I'd like to create a .cs file of some sort that builds an array. I want to do it a little bit differently though. I'd like to make sure that ours is a static method so that we can just call it directly without creating an instance. This code that we're looking at requires an instance, and we can try it just a little bit different. So I think in order to do that, I'm going to create a new class. So let's right-click on Sort Util on our project and add class. And I'm just going to call it sorter. Getting all fancy.
This is the class we're using to build an array to sort.
Uh-huh.
Wouldn't it be?
Well, we could put sorts in it too. Yeah, I think we'll put sorts in it too, and then you'll say that was really messy. We should do it a different way. There's so many ways we could do it. Okay, so in our class, let's first of all allocate that random number generator. So in our sorter class, our method to load our array, let's call it load array. And I'm going to make it static, and it's going to return an array of integers, not indexers. And we're going to accept as input into this method an integer that will be the size of our array. Kind of like that. Whoops. So we should be able to allocate an array based on our size. What do you want to call it? Data. So we'll say, oh, it's a new array of integers based on that size that we got passed. And then we can go into our for loop, and we'll just use an integer named I, start at 0. while I is less than size. We'll increase it. And then all we need to do is update the data at position I in our array, and we'll set it equal to a random number. What size, how big do you want these random numbers to be?
From 1 to 3.
That's pretty small. No.
Let's go higher.
Yeah, 100,000.
Oh, geez. 100, that's a great number. 100, I think that's a great number, you guys. We want to be able to read them.
Does that include 100 or is that 99?
It'll go to 99. And actually, it'll make us only have 2 digits in our print. So maybe it'll line up without us having to do a whole lot of work, because it always bothers everybody when it's all yucky. Okay, so after our for loop, let's return that array. So some things to think about here. First of all, I made this into a static method. I could have made it an instance method, right? But then they would have had to create an instance of our sorter class. Having it be a static method, it requires no instance. So people can just say sorter.loadArray, and then we'll return an array to them. So they don't have to create an instance of our class to do that. So in this example, we're actually going to return that array of integers back to our caller. So let's create another method here before we do any testing, because we're going to need to test this thing before we add any of our sort implementations. I want to do some printing, and they have some really fancy printing in theirs. I think we can get away with a little bit basicer of a print implementation. Let's try it. I want to make this another static method. We shouldn't need to return anything from our print method, because we're just going to write it out to the console. So we'll call it print array. And whoops, I changed my mind there. We're going to need that array passed to us. We'll call it data again. So all we need to do is a for loop. This time we'll have to base it on the length of our data array that was passed to us. And for each element, we'll just write it out to the console. We're going to use the write command because we're going to control the new line stuff ourselves. So what we want to write out is our data array at position I. And then let's do a couple of spaces. Now I think if we output, I don't know, about 10 entries, we should do a new line. So how could we do that? What kind of if statement could we put in here to check to see if we were on a 10th? That would work. So I would say if I mod 10 equals 0, then I want to write out a \n. Should we call it? Want to test it? Dr. Ford sending me messages, you know, you just gotta wait. All right, so I'm gonna go to my program.cs because if I remember right about console programs, you guys will have to help me here because it's been a little while. I should be able to make this my tester. All right, here's my main. So I'm gonna say that I have this integer array, the data, and I'm gonna set it equal to my sorter dot load array. And how many entries do we want? 100,000. That might take a minute. And then I want to print it. So we'll call our print array method, passing it at big data we just generated.
Why don't we just call the print array and the parameter called the load array? That's what I did. I just did, like,
No, because we want to give the user the control over when that print is called. We don't want to do that ourselves. They get to control it. Okay, so let's run it. See if we ever get anything out. I'm getting a bunch. It finally got done. I guess I could put in one of those console.read key things to make it stop. But it didn't take too awfully forever long. So let's put our sort in. In Canvas this week, let me show you what we've got. Is it still going? You guys have so many assignments. You're going to take me out. I have a death wish this week. So these ones, the piglet and bubble sort and bucket sort, are the project assignments. And these are the ones that are going to be graded. So these all have points here, but they're going to be in this category of not being graded so that I don't die. And you can always let me know if you want me to take a look at one and make comments for you or something. But so these are all recommended. The Rebel course is required. And then the code review that we're going to do next Wednesday is required. And in your code review, you should be prepared to explain one of these. So you want to do it. So we're going to do this bubble sort together right now. So this one will pretty much be done. But the bucket sort is going to be available if you want to try a more challenging one. So it's definitely more challenging. And the Pig Latin, I would recommend everybody do this assignment just because it really helps you a lot with string manipulations and some of those things that we haven't had a lot of assignments that do. But it'll be next Wednesday when you do this code review that you'll be telling us about one of those. I'm going to try the ungraded projects to see how that works. All right. So let's make that bubble sort. We're going to do it. I want to go back to our sorter. And I didn't document my print array method. I'm going to do that. 1, 2, 3. This method will print out the array entries. So now I would like to create a method to do a bubble sort. And again, I'm going to make this a static method. I want to just be able to call it directly. This is going to return the updated sorted array. And it's going to expect as input the original unsorted array. And again, we'll just call it data. So I don't have code for a bubble sort in front of me. We're gonna have to figure this out together. In our bubble sort, we would be looking at our array here, and we're gonna be kind of having some of the same kind of things to control our sort as we have here. But in a bubble sort, we want to scan for the largest element and move it to the end points of the array, to the high points of the array. So we need to have some sort of data element to hold that largest value that we've encountered so far. Let's declare an integer for that. That'll be one thing that we know we need. We know we're going to need an integer to hold that index entry. So let's go ahead and call it next. That word they have for insert, that variable, that's an interesting one. But let's just call ours save data, and we'll see how that goes. Okay, so we're going to need a for loop, right? And they used this variable next. Now I'm going to go ahead and type int next equal, and and they started at a weird spot. We're going to start at 0 and see if that's right. So why am I getting an error there? So what does that mean? Mm-hmm. How do I fix that? Get rid of the int. And don't forget, when you see that same error when it's talking about a class you made, it's still the same error that you're declaring the data type when you have already done that. And so you can get rid of it. Okay, so I've got a loop here set up, and now I'm starting at the very beginning item. So I think that if I'm starting at the first entry in the array, or whatever entry I'm starting at, I should say that entry is the largest, right? Kind of like the 3D scary guy did when he was looking for the smallest. So as we start out, I'm going to save that largest entry. Data next. Then I'm going to check, or should I do a while? Let's try a while, kind of like that code we were looking at. So if our entry that we've got is larger than the next one, we need to swap their positions. Does that sound right? So if I'm looking at data next plus 1, if data next plus 1 is less than the data we're looking at, should it be that? We could switch that and say, well, largest is greater than 2. So whichever makes more sense to you, since we're looking for the larger one. But if I see that it is larger, so I need to swap these entries. So I can say that the data at position next should be set equal to the data at position next plus 1, and the data what then? Is that all? Just move it? We could test it. Think it's missing some stuff. I'm going to go down to the end of our for loop and add the return statement to return our data array. And I think that if I'm going to be testing, I'm going to change my tester program to use a much smaller batch of data. So let's go back to our tester program. And I'm going to make it maybe have 10 entries. Now, after we call our sorter to print the array, let's call our sorter bubble sort. And we're passing our same the data array. And our bubble sort was going to update that. So we need to catch that output that it sends us.
Ms. Riley,
Mm-hmm.
does it in fact send back? Don't remember you putting your return statement in.
Uh-huh. Yeah, I had to put a return, but I'll go back and show you. And honestly, when we're working with arrays like this, if you guys remember way back to your C#1 days, arrays are always passed by ref, which means they're always passed by memory location, which means I don't really need to capture that return value because my original array is going to be updated and sorted. And we'll show that. We'll take a look at that and make sure you understand that. The reason I would put this code this way is for clarity for future people that are working on it so that they know that bubble sort method is going to update that array. Because I could really leave the data equals out and it would still update my array. But I want to make sure people on down the road know. Okay, so I'm going to turn on a breakpoint right here where I call the bubble sort. And I'm going to go back to my sorter and right there set down at the bottom of that bubble sort. Pop in that return data. So I feel my bubble sort is severely lacking, but not getting a lot of input. I'm going to go ahead and start debugging it. So here's my output. See, I've got, it looks like that first one made its own line break, huh?
Well, if module should be before it because 0 module is 10 0, so that's why.
So it's doing it. We'll have to fix that. All right, so we have these 10 entries in our array. So now I'm going to go ahead and step into, and it's going to go into our sort method. So here we are in our sort util class, and we're looking at our bubble sort method. All of our data items have been allocated, and we're going to start out with our for loop. Now, if I look at my data array here in the debugger, I should be able to see all those entries and see what order they're in, so I can tell what's happening. Now, if I F11, I'm going to save my current value, which is 13, in the largest variable. And then I'm going to say, is the data that's next door less than? And it wasn't. Well, that did something. But now 61 is lost, right? We don't have 61 anymore. So we're missing some stuff, huh? How could we handle that? What do you think? Need a temp? Where should we put our temp? Do you want to declare it up here?
Right at the beginning of the while. Or
Inside the while? Is that the only place we need it?
and you set it equal to the current value. So equal to just so it stores that value. So when it overwrites, it. And then after changing it, you can set the array x plus 1 equals 10.
After our while.
No, I'm sorry. Yeah, so underneath data, it should be data. It'd be next plus 1 would be equal to 10.
I'm going to give you control. You're going to take control?
Not really.
Oh, come on. You got thoughts?
I have set up, but I did 2 for loops.
Did you do 2 for loops? Well, show us what you did. Let's see your awesomeness. See what you did.
So all I did online was I did.
Oops, hang on. Let me see if I can get you over there just a second. There we go.
So yeah, all I did was I just set up a for loop in the beginning to initialize the array link that I typed it out once.
Mm-hmm.
So first it'll loop through the first part, and then I don't know.
That's okay.
I just remember this.
You're doing great.
Data structures.
Uh-huh.
Pretty much it sets the temp of the current array location of J, and then I don't know, it runs and it works. I don't know how to explain it.
Don't give us the power answer, please.
Well, that makes sense, isn't it? So for every time I changes, it runs J completely through the array to find the biggest one and put it out there. Is that what we got going on there?
But also with your 13 on top,
Mhm.
with the 4 I modules 10 in the beginning. So I mean, it still puts it there, but you can't notice it split your data when you run it. I just swap the position.
Mm-hmm. Okay. Well, we can do that. Help me, people. I'm going to put mine back out here. Maybe. I like that. So we'll just do another for loop. So let's see. What do you want to call this one? Inner. We started at 0, or did we start at?
You start at 0, and then enter key. I set a variable for it, but it's just your array length. But we can do data dot.
Okay, let's see. Let me get rid of some of this junk.
I mean, it might move through. I don't know how to push.
That's all right. We'll see. Okay, so, and then you had inner less than data length minus 1.
Okay, so the first outer array I have for int I equals 0, and then I is less than n minus 1 for the first one. And then for the inner loop, it's less than, so it'd be less than data length minus I minus 1.
Okay.
Or it would be minus next minus.
Okay. So let's get our loops in there. So in our outer for loop, we have a variable that's going to be controlling our index position. And we're going to run from the beginning of our array up into the second to last position. That's because that second to last position will allow us to compare to the last position without it canceling. Then we will compare inside the loop if our data at position inner
is greater than the inner plus 1.
okay,
And
then we want to swap them.
then it would be, and then I put an in temp equals array. Usually array inner. So I like right. So it would be array inner.
We got it. And then data at inner is going to be equal to the data inner plus 1.
And then the data inner plus 1 is equal to 10.
Okay, so we'll do our standard swap there, where we save a variable's contents, replace the variable's contents, and then update the third location with our saved data. You guys are going to have to give him a big round of applause here. Hey, Colton. Well, we got to make sure it works first.
Worked on mine at least.
It should work. It looks good. So we should be able to try it. Now, I think that I still have my breakpoint set in my test or my program. Let me clean up some unneeded variables here. And then we'll try it. Yep, I still have my breakpoint set. And I start execution. Here's my data entries with a couple of zeros. So what I'm looking here for a bubble sort is I might need to change the way I'm calling that print, because I kind of want to be able to print each entry each time we cycle through that bubble sort. So let's see where we want to print. I'll go ahead and run it to see. Now I'm going to go through our method. I'm going to expand this data array because I sure was able to see there was a problem before. And as I step through the outer loop, I'm going to go into the inner loop to process the whole array. So we just got that second number placed in our first position, and then we see that we swapped those successfully. Now we should swap the 73 and 74. So notice right now 74 is our biggest number that we've encountered so far. And it keeps bubbling towards the top of the array. Why they call it a bubble sort. Now 76 is going to be larger. So we'll grab that and continue on using that number. Now I got to go just a few more entries in that inner loop, and we should see that largest number bubble up to the top. So let's do some output. In our bubble sort, we want to print out after each sweep or pass of the array. So that's going to be in between our inner loop and our outer loop. So I'm going to put in a console.write line and something to say printing pass. And then I want to use our variable for outer, our next variable. And I want to and then I'm going to call our print pass array. And the array we want to print is our data array that we're working on sorting. So we should be printing out its current contents. Now, I need to fix that little bug in the print array. So I want to move this line to after our if statement. That should get rid of that bug.
I mean, it still puts it there, but
It's just you can't see it. You can't see it.
Can you go back up and things added?
Sure. In the sorter. Let me get back to it.
Like the print pass thing or whatever.
Yeah. There we go. So it is in between the two for loops. So every time the inner for loop runs, we want to print that out because we don't want to sit and watch it in the debugger forever. So now that we have that debugging code in, I should be able to eliminate my breakpoint because it's kind of tedious when we're doing this intensive stuff. And I'm going to try to run it. And I should see multiple lines of output for each pass. So this is what we want to see. The first time through, it moved that 93 up to the top. The second time, it moved the 88 up. Looks like it got 44 also by accident. And then 43 and 40. We can see how the largest number in our array keeps bubbling up to the top. Is it working?
Can I see the print array?
Mhm. So we just moved our print on after that if statement, so it would be. I better get all this stuff before that class comes in here too. They're going crazy.
They were here last time we left. Like, oh, I'm still in there.
I know it's
like
like
2
Lord,
minutes
that's
now.
really like that. Sorry. Yeah, put all your stuff away. Cause being there, it's like weird and get in. I don't know if that class got moved, but I heard him say, "We're not gonna get moved again, are we?" So I think they maybe have got moved. Very bad. All right, got them all.
So we had to do counter sort stuff. And I did 100 million. And so I've been running it since 9. Yeah. And I'm only on I'm doing 0 to 9. I'm just seeing a big head.
Just a resource hog.
Well, and like it already knows, it's already sorted. It has a checkoff in for now. It doesn't know that it's sorted. 862 megabytes. And then I might get the gigabyte. It has to check it to see if it's sorted. So this is what we have to do.
I think that's really cool stuff.